Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today, rank transform of an array, Leetcode 1331. In this problem, we are given an array of integers r and we have to replace each of its element with its rank. The rank represents how large a number is. The rank has the following rules. Rank is an integer starting from number 1. The larger the element, the larger the rank. If two elements are equal, their rank must be the same. Rank should be as small as possible. That is, we cannot skip the rank. For example, if two elements in the array are equal, like 10, 10 and 20, then the rank will be 1, 1, 2 and not 1, 1, 3, right? Because sometimes people skip the rank and here we want rank to be as small as possible. Then in example 1, for the given array, the ranks are 4, 1, 2, 3 and the reason is when we sort the array, we get sorted array as 10, 20, 30 and 40 and the corresponding ranks are 1, 2, 3 and 4. So we assign 4 to 40, 1 to 10, 2 to 20 and 3 to 30. So that's why the output is 4, 1, 2, 3. Then in example 2, all the elements are equal and all of them are equal to 100. So we will assign the rank 111 to each of the elements. And suppose in example 1 we had the duplicates as well. Then for example the array was 40, 10, 10, 20, 20, 30. Then if you would have sorted the array with the unique elements, then it would have been 10, 20, 30 and 40 and ranks again would have been 1, 2, 3, 4. So our output would have been 4, 1, 1, 2, 2, 3. Now in terms of solution, one of the naive approach can be that for each element we count how many elements are smaller than it and count plus 1 will be the rank for that element. By doing this for each element, we could determine the ranks without having to sort the array or using some additional data structure. But the time complexity there will be O of n square, which is super high. Then another approach can be, since we need to replace each element with its rank, we need to find the smallest element and assign the rank to it. So the easiest way to accomplish this is by doing the sorting of the input array in ascending order and then associating each element with the rank. However, sorting the array directly would lose the order of the original array and we want to return the array of ranks based on the input array's order. So we should take a copy of the array and then sort the copied array. The rank starts with an initial value of 1 and since the elements can be duplicate, we cannot simply use the index from the sorted array to determine the rank. So to handle these duplicates and to efficiently check and assign ranks, we must use some data structure like hashmap or dictionary so that the lookup time reduces to O of 1. So to calculate the rank of an element in the sorted array, what we can do is we can initially assign the rank equal to 1 and start iteration on the sorted array. And whenever we see that the element is not present in the map, that means this element should get a new rank by incrementing the rank by 1. And if the element is duplicate, then we know that we have already assigned the rank to it. So that's how the whole logic will continue. So now let's see this in action. Suppose we again take our input array as following. Now if we take the copy of this array and sort it, then it will be as follows. And now we can assign the ranks for the elements in the sorted array. Initially rank is equal to 1. So we can see that 10 is not present in the map. So we will add it to the map and its rank will be 1. And now we increment our rank to 2. Then we see 10 again. We see that 10 is already present in the map. So we do nothing. Then we see 20. So this is a new element. So that means we should assign a rank to it. And now its rank will be 2. We increment the rank to 3 now. Then we see 20 again. So we see that this is a duplicate. So we don't have to change the rank here. So now we come to 30. We see that it is not present in the map. So we assign it the rank 3 and increment the rank to 4 now for the next element. Then we see 40. So now the rank is 4 because it's a new element. Now we increment the rank to 5, but we are done with the inputs from the sorted array. And now we can create a new result array. And for each element in the input array, we will assign the rank to the element in the result array using the rank map that we have just created. So first element is 40 and corresponding rank is 4. So we assign rank 4 to it. Then we see 10. Corresponding rank is 1. We again see 10. So we assign the rank 1 to it. Then we see 20. 20's rank is 2. So we will assign 2 here. We will again assign 2 here. Finally, we see 30 and the corresponding rank is 3. So we assign rank 3 to it. And now we are done with all the elements in the input array. And hence we will return result array as the output. So now let's jump into the code part. So first we check if array length is 0. Then we will return the empty array itself. Otherwise, we will create a copy so that we don't lose the order after sorting the elements. Let's call it sorted array. And in Java, we can use copy of method where we can pass the original array and the length of the new array that we want. And here we want the full length to be copied. Then we just sort this array using arrays.sort method. Now we can create our rank map for each unique element in the sorted array. Initially rank will be equal to 1. So now we can start looping on the sorted array. If the rank map doesn't contain the sorted element, then we should add it to the rank map and we should increment the rank for the next iteration. Otherwise, we would have already calculated the rank of the element, right? And now we will just create our result array to return the ranks of all the elements. Oh, here is a typo. There should be T here. So now for each element in the original array, we will just get the rank from the rank map and assign it to the result array for the corresponding index. I just realized I should have used variable n for array.length to save some time, but I think now we are at the end of the logic. So now let's return this answer. Let's run this code. Let's submit this code. Cool. In terms of time complexity, it will be O of n log n, where n is the length of the input array, because first we are sorting this array that takes O of n log n time, and then we are going through this sorted array that takes O of n time, and finally we are filling this result array that again takes O of n time. So the overall time complexity will be O of n log n, and in terms of space complexity, it will be O of n, because first we are creating this sorted array that takes O of n space, then we are creating this rank map that again takes O of n space, and finally we are creating this result array that again takes O of n space. So overall the space complexity will be O of n. I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or suggestions, please write them in the comment box. Thanks for watching. See you next time.